The initial value of theorem, given that for x for n equal to 0 is equal to limitation z approaching infinity xz. So based on this equation, this is the general equation for z transform, and if we apply this range into this equation, we have the series of this signal. It can be seen that as z approaching infinity, the term z negative n is approaching 0 for each n larger than 0. Okay, so we have this equation. For example, you are given this value of xz equal to 3 minus 4z divided by 1 minus 2z plus 5z squared. Okay, now for initial value theorem, for x at n equal z at equal to 0, and x at n equal to 0, so in z transform, we apply the limitation of z approaching infinity into this signal. So for this one, okay, we should rearrange this equation into this format. So we can cancel this out, and for this one, when we apply z approaching infinity, we have the answer of 0. So the initial value for this function of xz is equal to 0. So the next property is final value theorem. When x n equal to infinity, so the z transform is limitation z approaching 1 multiply with function of 1 minus z with the power of negative 1 xz. So this is based on the linearity and time shifting theorem with initial condition equal to 0. So for initial condition equal to 0, we have this function where when we simplify this one, we have 1 minus z with the power of negative 1 xz as stated in this equation. For example, based on this equation, so we apply the general z transform equation with this limitation and approaching infinity with this range, and then we apply the function of 1 minus z with the power of negative 1 multiply with xz for this one. Okay, now we let z equal to 1, then we can rewrite the above equation. Limitation of z approaching 1 multiply with this function 1 minus z with the power of negative 1 multiply with xz. So we have two limitations here. The first one is the original limitation from this part, and the second one is from this part. So the next one is we rearrange this equation into 1 over z with the power of k, and then for this part, for z approaching 1, when we apply to this one, it is equal to 1 over 1. So we have this one equal to 1, so only this part left in this equation, and then we apply the range of this k equal to 0 until n in this equation, and for n approaching infinity, so the signal is equal to x infinity. So this is the final value theorem. X infinity equal to limitation z approaching 1 multiply with function 1 minus z with the power of negative 1 xz. The next one is example for final value theorem. When you are given xz equal to z minus z divided by z minus 1. So for final value theorem x infinity, we apply the limitation of z approaching 1. So for this one, multiply with z minus 1, or it is equal to 1 minus z with the power of negative 1, same as the formula given in the previous slide, multiply with exact. So you substitute exact into this equation, you cancel this function. So we have this function, when we apply the limitation of z approaching 1, we have 1. So the final value of this function is equal to 1.